All right. Well, it feels weird giving myself an introduction, but I guess I will. This is the first time I think I've had to actually speak in this series of brown bags. So I am Jason Zurawski, normally the host, and I'm going to be talking a little bit about an upcoming event that's going to be co-located with the CICI STARRP PI meeting in Minneapolis. And what it is an attempt to do a little bit of a community reset on data movement and how it relates to scientific users and infrastructure that we've all, and many of us have installed as a part of the CC STAR set of grants. So because this is a day before Labor Day weekend here, I had a lot of fun putting this talk together. So I'm not going to take myself very seriously. I hope that none of you take me very seriously as well, except for sort of the ending message that I'll try to leave everybody with. So you'll notice some themes as we go through this. I will start off with a bit of an apology. I'm going to be abusing some classic music here as I go through. I was more partial to the remake anyway myself. But, you know, in keeping with the theme here, there's a couple of Easter eggs and little quizzes and opportunities for people to be a part of this talk as we go through. I have no ability to see the chat, unfortunately, so I will not be able to answer the chats until I close out of the talk a little bit later. So if there are audience participation questions, we'll have to bank them up until the end, and we can sort of do it that way. But let's get started here. This whole event came out of observations that myself and my colleagues via the EPIC grant have been making for the better part of a year, and maybe even a little bit before that. We, via this grant, have been trying to go and talk with scientific users that are positioned around the country as they do their work. And we often will talk with the individual research groups, and we'll bring in the IT groups, many of you, as we do these talks. But we're seeing some common patterns that are emerging. And one of the things that it's always good to point out here is that we do have this great map that's showing what's happened within the CC STAR program over the past 7, now going on 8 years if the next round of solicitation comes up. $100 million in investment and about 130 campus networking upgrades. There were other pieces of this grant program to fund CI engineers and research projects and some other little bits and bobs as well. But for the most part, the majority and the biggest investment here was in campus network upgrades, technology to support the end users. But what did that do at the end of the day? If the goal and the stated goal that we all sort of think in our mind is that we're trying to build cyber infrastructure, I would claim that this has been a little bit of a failure. We should not be just trying to build things for the sake of building things. We should be building things and then being able to go back and tie these to the individual users and groups and things that populate our campuses and our facilities, and be able to show them that, hey, look, this helped you. This was useful in trying to bring forward institutional, if not cultural change in the way that we are doing our science. And whether that be by upgrading the networks or the storage capabilities or the computation, I mean, the list goes on and on of things that we have lumped into the category of CI these days. But can we go back and show all of these different individual goals? It isn't just about installing a new border router. What are we using it for? How are we able to measure this? So here's the first Easter egg, and I'll leave that as an exercise for the reader here. There is a little bit of a disclaimer there about when you can cash in on it. So if you think you can answer that question legitimately, plunk it into the chat room, and I'll deal with it at the end of the talk. Did all this CI infrastructure that we built work as expected? Are we all satisfied? And all here is underlined because I would count that the researchers are really the survey population that I care most about, not the IT people. And how do you know when you're done? How do you know if you've done a good job, and how are you able to really say, okay, we don't need to do this anymore? I would claim that we're really never done. This should be a constant process that we're all sort of being a part of. I would claim that also building CI for the sake of spending money and just doing upgrades is also not really the best use of our time or our effort within this community. You know, we're all going to mess things up, and we're all not going to approach this from the right angle to start off with. And in fact, any project that really we go into, we should be thinking that we're going to have to redo this, because there's no way that we're going to be able to get all of the user requirements right off the bat and be able to deliver a fully turnkey system that we can then deliver back to these user communities that are supposed to be using this CI infrastructure. And it's still not a success unless the researchers are happy in this. And yes, they're a fickle and mercurial group of people, but we need to make sure that we're building the things that they need and want and desire as we're going into this. And we could do another show of hands here. How many people went back and verified these things as they were building this? I would claim it's not a very large number. With some of the engagements that we've been participating in, we're learning that a large population, and prove me wrong if this angers you in any way whatsoever, I'm not here for a fight, but I am here for a good conversation, is that a lot of people miss the mark on this. And we can say that we missed the mark in a couple of key areas, whether it be the network infrastructure may not be capable of passing the levels of flow traffic that we need to do to accomplish bulk data movement. It may not be providing enough access to or help with utilizing computational resources. It may be that there is not enough, or any for that matter, storage that's available for the research community to do what they need to do, forcing people to cobble together solutions that are very suboptimal for the workflows that we're trying to help out here. And then lastly, the social aspect, science engagement. If you aren't touching base with these people, especially if they're named in your grant, but, really the entire population on a routine basis, you're really doing it wrong. And this is something that we've been trying to change as best as we can, even though we're a small team of people and there's a whole lot more of you out there. We need to re-engage and make sure that the scientific community and the vice president of research for your facility know who you are, because they're the ones that are going to be controlling and helping to upgrade this infrastructure once that initial round of soft funding is gone. Everybody knows this. This is what we've been trying to preach for a number of years, and it's a little passé at this point because people know what it is, and we know that we're trying to build these friction-free networks and have dedicated machines for the job of data transfer and visibility through measurement. But that last step is the thing that wasn't necessarily directly funded via these CICI STARRP programs. It was always a wink and a nod. Yes, you should do this. You should go in and you should talk to your users. But without a dedicated person, a dedicated resource, or a dedicated charge to do it, it's the last item on the list of things to do. And this is kind of critical, because when we get into how people are going to be using this infrastructure, we do a good job of building it and speccing it, and we cut the ribbon on it and we open it up to allow people to go on there and use it. But then what happens? We still have users that are plunking down performance data transfer infrastructure into areas that cannot accomplish the goals of data transfer because of the way that it's designed. We're still seeing lots and lots of problems related to performance that we can gather from our tools, but if we're gathering them from our tools, how come we're not going out and fixing these things? And we're still seeing the fact that the Wizzard Gap is a real and a very prevalent thing within our community. If you don't know how to leverage this infrastructure as a user, you're sort of out of luck. And we can go in and do the direct engagement with people on a one-on-one basis, or we can sort of lower the bar and make it such that we don't have to worry about things like this. So we've encouraged this. We've encouraged the use of this infrastructure that is the first step. And I'm going to say first step because there's a whole lot more stuff that has to be built on top of the infrastructure once this is in place. I don't mean to call everybody out in this, far from it. I really want this to be more of a community reset. And one of the things that I'd like to start talking about when we're in Minneapolis or at other community meetings is that it's time to redefine the mission, the approach, the solutions, and the success metrics here. The social conversation of trying to link together the support of technology and science needs to be the leader. It shouldn't just be, hey, here's this cool thing, let's install this and use this, because this doesn't help as much as we all think it may. It distracts away from trying to establish this trust and building useful infrastructure. One of the things that you learn is that when you're sitting behind somebody and watching how they interact with technology, is that they're probably not going to do it the way that you had in your mind, or that the way that you prepared the things that you're about to do. Everybody is going to be approaching this a little bit differently, so it's important to understand that social aspect. It's important to look at the way that they view the world, whether it be through software, whether it be through hardware, or if they don't really care about how they view the world, they just want something to work. And all of this really begs us to go back and revisit this, and not just implement technology for the sake of implementing it, but to put it in place and to carefully measure and figure out how it is being utilized. There's all kinds of things that have been thrown into our world at this point that can be counted as CI, whether it be the network, or whether it be the computation, whether it be the storage, or all the policies and stuff that live on top of it. And I get it, that's hard, you know, but we still, at the end of the day, have these problems where somebody comes in and they're trying to just move data, a very simple task, something that all of us do routinely on a daily basis. And who has tried to send a more than a 25 megabyte file via email in the last week? I'm sure everybody's hand is going up, right? And all of this stuff exists out in our world. And I don't like the expression "eat your own dog food" because I don't want to eat dog food, but we have to learn how to integrate this into the world so that we don't have to ask questions like this anymore. There are lots of pressures on all of us. Network, hardware and servers and software and all the stuff that we need to do is expensive. And there's often a temptation to go cheap on one so that we can offer more service on another. And I get that. We're going to have to do that in certain areas. Some of this stuff is really, really hard to do. And it takes people to design it, build it, operate it, and time. And time is always the most valuable thing that we have to deal with here. It takes time to build trust. It takes time to have conversations with people to figure out what they want. Consensus certainly isn't easy. Frustration is a very common thing as we go about this, especially when the research community may not know what they want, need, or desire in this case. But the core goal here is that what they do need is help in moving information. They need help in that aspect of their pipeline. A lot of them can figure out how to do the computation on that information once it lands where it needs to go. They can figure out curation. They can figure out stuff like that. But data movement, that's our world. That's what we are building this infrastructure for and trying to support as best as we possibly can. What we're doing here, though, is we're building investments in the future. We want there to be this selling point for our faculty and for our staffs that we are building something that is a very critical and very important part of our infrastructure. You know, we want it to be scalable. We want it to be able to be useful for a wide group of people. And we've done a good job, at least I think we have, of building a community of lots of smart people that know how to do these things. And almost all of them will answer your questions if you ask. It's just that you have to ask, and you have to be ready to hear probably a different answer than what you may have planned out initially. We are very cognizant that time is this most valuable commodity, so spending it wisely is one of the things that we want to try to do. I still would advocate, though, that your time should be best spent on that social aspect, watching what the users are doing, figuring out what they're doing. You'll learn a lot more than asking them, what do you want? Because the answer is always going to come back, I want all of it, or I don't know what I want. And that's frustrating. So if you can watch their process, figure out how they're interacting with the world, you're going to learn a lot more about how to support it. We've built this requirements review process within ESnet, and now something that we're doing within Epic over the course of about 10 to 15 years. And the purpose of this process was to accurately characterize the needs of the scientific community and try to put a pin in the ground about how to predict their growth patterns and predict where they are in their technology adoption life cycle, and figure out where the areas of friction are going to be. This has been our method for determining network requirements for the customer base, and it's been pretty successful because we've been using it for 15 plus years at this point. And it's not challenging. It's asking simple questions. It's asking what's the science that's happening. It's asking about the hardware, the instruments in the facilities. It's asking about the software. It's asking about the process that somebody goes through to do the things that they need to do, and trying to put a time scale about how these are going to remain the same or change over time. This gives you a viewpoint into where somebody may be within their life cycle. if they're still at the point where they are not involved heavily in team science, if they're using local instrumentation and trying to do all the work on their laptop, then they may be ripe for coming in and having somebody show them, here's how you use Exceed, or here's how you can utilize institutional HPC or storage capability, or there are better machines over here for your genomics work or your light sequence or your light source microscope work. Why don't you try to use that? We've already established this pipeline that allows the data to move there. These are things that help accelerate science when you're talking to the individuals and trying to get them to do this. This allows you to gather this critical information about strategic programs. It allows you to gather critical information about network and technology organizations as well, so that you can try to guide their strategy. It allows you to serve as an interface to higher level programs and use cases. Getting this in front of the decision makers is an important thing, but it also helps you get these relationships established with your constituents. Once you build these relationships, you can identify issues a lot easier and hopefully deliver solutions that are more tailored to the things that people are trying to do. It allows you for the identification of common patterns and problems and solutions, all of the things that the technology was designed to do. But that sociology and psychology, that's the key part here, because you can build it and it may be available, but if somebody doesn't know how to use it, there's not enough energy in the world to get them to move off of that ring. You need to be able to either do it with them or show that there's going to be a clear and tangible benefit. Otherwise, it's not going to happen. If we look at the way that this has helped different groups, large collaborations that have dedicated teams of people who do these things, they know what they're doing, and they've built this knowledge over decades, and they're able to be very successful as they do this. It's really that other end of the scale, the green triangle end of the scale there, that need the most help. And these are the individuals or small teams of people that are going to be populating all of our campuses and facilities. And spending a little bit of time with them to accelerate their process is really the best thing that you can do. We want to get away from this. I'm fond of using this picture in a lot of the talks that I give because I think it explains our world very succinctly. We spent a lot of time designing, but the user is going to do what they want to do unless you can show them that there's a better way to do something. So let's talk about what's going on with scientists these days. And we're going to use a couple of little examples here. In this case, climate science, you can substitute in cosmology or astronomy or anything else, but most forms of science are going to revolve around the principle that you're going to have data sources. You're going to have people that want to have access to those data sources. And once they receive those data, that data via network infrastructure, they're going to do something with it, whether process it on computational resource or visualize it, whatever the case may be. But there will be lots of these forms of repositories of information, and people will either be pushing or pulling from them. And the typical way that the scientific community interacts with these things is via the concept of a portal. So this is an example of the NCAR one, if you want to take a look at those right there. And there's various data sets, and the data is always going to keep growing. We're going to have larger data sets. We're going to have more of them. What do you do with it? You download it. And where do you download it to? You typically download it to a supercomputing facility or perhaps your home institution. So my colleague Eli Dart did this experimentation starting about a year ago and was downloading via this infrastructure here, a portal infrastructure, and saw those performance numbers to a number of DOE sites. So not bad, but could we do any better here? This is what the scientific community sees. They see the science application. They see the portal software. They see the workflow tool. They see the ability to receive their information. And that is their view of the world. They don't really care about all the stuff that's underneath. That's our job, to build the stuff that's underneath. But a lot of these legacy systems and scientific groups that are working together may not have put the investment in place to fully utilize that underlying technology. They still may be using classical interfaces that are just based on regular old HTTP and not able to take advantage of the faster tools that a lot of us use in our daily lives, whether it be something like a grid FTP or a Globus or an FDT or an Aspera. Any of those things are not really put into the viewpoint of the scientist unless they've taken the action to go out and learn these things. So if we can force a transparent change under the hood to improve these portal softwares, we can easily get in there and force this change all in a way that's not very intensive or scary or dangerous to the scientific communities. So what we're saying here is that these new forms of access to the data should be built on top of the science DMZ model. And once that's in place, we should be looking at what the performance characteristics are between the various large facilities that are within the country and the end users and the campuses and the storage locations and the computational locations and the instrumentation facilities, all the different pieces of the scientific conveyor belt, so to speak, of getting this information moved around. So Eli embarked on this starting about a year or two ago and made some observations. And this was starting, or I guess ending, in March of 2016 using a very specific data set that came from these different scientific groups, and just did a full sort of mesh test of everybody to everybody and wrote down the results. And you can see here that these are still nothing to sneeze at. These are still pretty good, but could we do any better? Now, bear in mind, this is also big, large-scale facilities. We're talking NCSA and NERSC and Argonne and Oak Ridge, big facilities, dedicated teams of people. All they're doing is firing all day long on information moving in and out. But in some cases, we're still seeing sub-10 gig performance between some of these facilities. It takes a lot of tuning and a lot of work and a lot of effort to get these things tuned up, but approximately a year and a half later, running the same stuff after spending all that tuning effort, it's possible to get orders of magnitude improvement. So where we were seeing sub-gig performance in some cases, now we're seeing maximums that are above 30, and in some cases maximums that are above 40 or 50. And this is something that is a little bit time consuming, but at the end of the day, what does this do? This smooths out the pathways. This paves the roads. It makes sure that all the infrastructure underneath these data movement tools, portals, whatever the case may be, is working as best as it possibly can. And now when a user comes in and tries to leverage these resources, they're going to work out okay. This is a small-scale effort. It's between 4 different things. Why couldn't this be done community-wide? Why couldn't we, as CI engineers and friends of CI engineers for all the different institutions that have received this funding, all 130 of us, why can't we spend some time to measure, improve, and publish the results of trying to move data sets between us? So that's really what I think that we need to be moving towards. These different large repositories of scientific data, the larger ones at least, have already invested in trying to make this stuff better, but not everybody is really there. A lot of these portals were designed 15 plus years ago, which basically means that they are the single web server design where somebody is going to be using web browser of the day to log in, pull the information down using simple HTTP, and then do something with it. This is not the recipe for success, because what does that look like? It looks like something like this, where we have our single path that's going to be going in. In many cases, if this infrastructure has not been touched as a part of the CICI STARRP upgrade process, it's going to be going through the enterprise network. It's going to be going through the firewall. And that portal application is your single web server, hopefully something modern, but probably not. And all of the functionality that's built on top of that, search, database, authentication, whatever the case may be. It's rickety, it's old, it's functional though. And because it's functional, it's one of the reasons why it stays in place. There often needs to be a big kick to get somebody to move off of something that's working, but just not working very well. And what could architectural change look like? Well, it means going in and trying to redefine all these different parts, which is hard, and it's also time consuming, but we do need to think about this, because until we do, This is the way that the scientific community interacts with their data sets. Until there's a better way, until there's a way that they can do this in a more efficient fashion, we're not going to be able to fully leverage all of that infrastructure that we spent all that time putting in. So starting about a year ago, maybe even a little bit before that, there was an effort by a bunch of different people, including the people at Globus and some of the larger facilities, to try to disassemble this portal architecture and put the pieces back together in a different manner so that we can take advantage of that technology that underpins it. So we take a look at what we had before. What does it look like if we were to bolt on the use of that infrastructure underneath it? Well, it's the Science DMZ designed, but supercharged such that we can take advantage of where the data lives. So instead of going through the data path that takes us through the firewall and the enterprise network, we change the data paths specifically to leverage the Science DMZ architecture. We probably have data transfer nodes already stationed on our campus infrastructure. They probably are running a modern tool like Globus. Using some of the APIs that exist, why can't we build a better portal? Why can't we have that access the file system on the back end, stripe it across as many instances as we possibly can, and then expose that out to the user? We could still keep things like the browsing path and the query path the same, but this tiny architectural change is what gets us these better performance numbers. Because if the data path is simplified, just like we did with the Science DMZ design itself, we're able to take advantage of the movement characteristics and hopefully do a better job and serve our scientific communities better. The portal is still its nominal self, but it's enhanced in this case. The GUI, the database, the search, all that stuff works as it does before. In fact, that's the stuff you really don't want to mess with, especially if it's working well, right? You know, getting in there and messing around with somebody's 15-year-old legacy code that's handling database and search activities probably isn't the best use of your time. But what you are munging is the data handling aspect. You're making it separate, you're making it scalable, and you're allowing it to use these new investments that have been put in place. This has been done for a number of portals, whether it be the JGI portal or the NCAR research data portal or a number of others as well. So why do we want to do this? Well, you know, we're talking about data sizes in a number of scientific disciplines growing, where megabyte is no longer the common term that we're hearing. We're hearing giga, we're hearing tera, and pretty soon we're going to be hearing exa and peta that go beyond that. Look at any long tail graph. We're seeing shifts here because instrumentation is getting more exacting, and the use cases and real-time requirements for this data are becoming more exacting as well. Modern data analysis on HPC has the ability to use a lot of data, thus we need to move a lot of data to where it needs to be, and this is the mechanism to do that. If we can retrofit these existing data portals that are out there, and there's no shortage of them, this allows us to take full advantage of the resources and the infrastructure that we've put in place. This is just another couple examples here of how people can use this information once it's put in place, whether it be climate or cosmology or whatever the case may be. So let's kind of get to the punchline here, is that we need to upgrade these legacy data portals because they are a product of their time and their time is up. So I'm calling for a charge within our community here to really start to pull together the software piece, the piece that sits on top of this, so that we can take full advantage of the network infrastructure that we've put under the hood. The scientific communities are not going to do this by themselves or for themselves. They have limited resources, especially if we're talking about smaller groups, but we all have resources, whether we're a campus or a computing center or a data repository. We're going to have to do the work if we want people to use this, because otherwise we're not going to be able to really prove that the work that we've put in over the past 7 years within this CICI STARRP program, that 100 million, is being adequately spent and operated on trying to improve outcomes for scientific users. So it is going to be a community-wide effort, and it's people on this call, it's people that are elsewhere as well. We need to help, and we need to be a part of that conversation, because, hey, it's our resources that are under the hood here that are going to be delivering these different things. It's all engagement. It's mostly social. the work to actually convert and do this is rather minuscule when it comes down to it. Use of an API to convert an old data portal is not hard. And you throw your research programmer at this problem, they'll probably have it done by the time you go and get them a new cup of coffee. It's something that can easily be accomplished within the sake of about a year. If we look at the scientific complex, there's a whole lot of stuff out there, and it's all complicated and it's all intermeshed, and there are many other problems that we as network people and technologists are going to be dealing with at the same time. But what do I see? I look at this from the standpoint of all that investment means we have DMZs at many of those places. We have data that lives behind those DMZs. We have high-speed DTNs and high-speed software that is able to access it. It's all just being able to plug those together, and that software piece is really the thing that has to sit on top of that and deliver these. So let's look at a little bit of a timeline here about where we're sitting and where we need to go. Within the last 10 to 15 years, we've made a lot of progress. We started our own requirements analysis process in approximately 2005, and that created the Science DMZ pattern. By about 2011, science engagement was now not just something that we were doing with Found Cycles, we were doing it as a career and something that has grown at a lot of the campus levels and facility levels throughout the years here. We started the OIN workshop series to do the training so that people can understand how to build and leverage these resources as well. But out of those came other lessons too. Not everybody needs to know how to build it. People need to know how to use it. And that's really the next step that we're going to be getting into here, is that we need to learn how to use it more effectively, whether it be building this software infrastructure on top of it and trying to get the end users to leverage it for their advantage. And what does that mean? That means that Science DMZ needs to move from just being a pure networking technology to something that's a little bit higher in the LSI stack. We need to build stuff on top of it. We need to be talking with people on a more regular basis so that we can evaluate the metrics and the process and the successes, really. And that's how we're going to make this into a scalable data platform. So what's the ask of all of you here? I motivated this for a good 30 minutes. What do we want to do? We are going to be having a three-part event that starts in September of 2019, but is going to extend for about a year afterwards, and hopefully take place again at the next meeting where a lot of us are going to come together. This is going to be at the NSFC, CC STAR, and CICI PI meeting in Minneapolis, and we're going to be posting this as three different things. It's going to be a workshop, and these are really the same workshop. One is just in the morning and one is in the afternoon. One is for the people who are brand new to the CC STAR program and may not know this technology and may not know what we're talking about. So we're going to try to level the playing field and get everybody speaking the same language, so to speak. The second part is for the people who, quote unquote, know better, that have their infrastructure in place. They've already had an award. They've already integrated these things into their world to a certain extent. They're going to learn about the portals, and they're going to learn about how they can integrate this and work with their users to put this up on their campuses. And then for everybody, and not just the CC STAR winners, anybody who wants to participate, we want to do a large-scale data movement exhibition. We're not using the word challenge. We're not using the word competition, because that's the wrong way to couch this. This isn't a competition. We want to improve science. So from that aspect, yes, we want everybody to be as competitive as they possibly can to make it such that their fusion reactor people are getting the best out of their network. But we want to understand what the current performance characteristics are of the networks today using existing tools. And we want to spend about a year making them better. We want to go from the 6 or so gigabits per second that we were seeing within the petascale world and move it up into the 20s, 30s, 40s, and beyond. Because once we have that evidence written down, it makes it a lot easier to convince people that this stuff is here to help and it's achievable and any scientific group can use it. And that's the way to roll the snowball and get more people involved in it. So if you are on site and you haven't registered yet, or you want to go back and change your registration, the workshop registration is open. This is sort of what we're going to be doing throughout that event. It's going to be on Monday, and I believe that's the 23rd of September. In the morning, it's going to be review if you've seen this stuff before. It'll be Science DMZ architecture and TCP and data transfer and all that stuff that a new PI or a new site that's never really experienced a lot of this stuff may not have had a chance to do before. And then the afternoon is going to be how to get this working with Globus and how to build a modern research data portal on top of it. The intro workshop is going to look very similar to OIN, but it's going to be pretty short and purely focused on just getting the ideas in place so that people can understand this and be able to go back and repeat it to their engineering staffs. We're also probably going to do some webinars in the future, probably using the CI engineering brown bag calls as the venue for that. The advanced is going to be a little bit more immersive. It's going to be providing a blueprint for how to do this on your home institution, and it's only a half day, so we really can't do a whole lot in that period of time, but it's going to be enough to show you that there is software, APIs, and have you walk away with the ability to integrate this in to whatever portal software happens to exist out there today. The data movement challenge itself, or the exhibition, I guess I broke my own rule and called it a challenge. This is open to everybody. And we want this to be a full year event. And because it's going to be a full year event, there's no official flag down time. But we want people to tell us what your performance profile is as you try to download information from a couple of data sets that we're going to place around the community. And we're still working this out. But it's going to look a little bit like very specific endpoints that will have a data set. People will be able to use their existing DTNs to download and measure that performance information and then submit the information to us so that we can hold on to it. And then if you want to work with us to potentially improve the performance, that's something that we can do as well. In fact, we're encouraging that step. Because odds are it's not going to work right the first time, and there may be ways that we could look at the architecture of the network or the DTN itself or the software to figure out what's going on and how we can try to fix it. So this officially begins in August, although August is now past us, so that really should say September. And then we'll continue on for a full year through the next CICI STARRP meeting, where we'll have another talk that goes into what we learned over the course of doing this event for a solid year. So how do you participate? We are asking people to do hopefully not a very onerous process of describing what your network and data architecture looks like. Preparing a data transfer machine, perhaps it already exists, which would be good because we want to use operational hardware. We don't want this to be stunt machines. We don't want this just to be something that you set up just to participate in this sort of thing. This should be what your scientists are using. So if you have a scientist and they have a DTN, go use theirs because that's really the data that we need to try to get to make this better. Download some reference data sets. We'll be sending out instructions on how to do this very soon, probably next week or the week after. And then share the results back with us. And for those that do want that help, Epic is there, or ask on the Cyberinfrastructure mailing list. I'm sure everybody would have many, many things to say about how to improve things. When we're at the event in Minneapolis, come by and talk to us. I'll be there all week. I'll be in the workshop. I have a couple of other things that'll be going on, but sit down and let's talk about what's going on and how we could help with your testing strategies. At the end of this, we do want to write some form of either white paper, BCP, or just general presentation that we can give back to the community, though. I always show this in my talks, too, because I presented a lot of stuff to you, and I can't make you care, but I can compel upon you that this is an important set of information that I've tried to give to everybody. So why should you care? We can't really declare success or victory in this space until data movement isn't a thing that we have to talk about anymore. I don't want to have to go in and give the old Wizzard Gap talk. I don't want there to be arguments about tools and protocols and procedures. I just want it to work. And I think the scientific community kind of wants that too. There's always people that are going to want to tweak and they're going to want to stick their hands into the machine and see if they can milk a little bit more performance out of something. But until the standard of, hey, I want to move data so that I can, run my simulation is solved, we all got a lot of work to do. The big scientific communities have made these investments already, and that's why I don't really spend a lot of time focusing on that. You know, I don't need to go in and tell CMS or Atlas or a lot of people how to do this. They figured it out. In fact, they tell me things. The medium ones, the small ones, these are the ones that we have the biggest problems with because they're not a team of thousands, they're a team of one, maybe one and a half. And they need the help in trying to integrate this into their world as best as they possibly can. So in my mind, what does success look like? We want to have improved scientific outcomes. We want them to be measurable. We want them to be verifiable, both very critical and important things. We want happy users, and not just the heavy hitters here, the little guys that are somewhere deep in your campus right now that are trying to use a ionic spectral analyzer of some sort and trying to move the information to their collaborators across the world. This needs to be measurable and verifiable as well. We want justification for all the upgrades that we just made, because the little cash injection that you get is enough to get you started, but that stuff's going to age out at some point. You're going to have to go back and talk to your campus people, whether it be the vice president of research or your chain of command, that, hey, this stuff's going to need to be upgraded soon. They're going to ask, are people using it? And if we can't go back and prove that this stuff is being used and leveraged to do the important work, then what have we done? So that's what I had. I'm gonna leave this slide up, but what I will do is I will get out of this slideshow itself so that I can actually see the chat window now. So I see that nobody has decided to answer the two questions that I had posed. The first question was, can somebody show a scientific outcome that they can prove happened as a result of their CICI STARR investment? So I guess nobody gets the free beverage on that, but I'll still leave that one up. Whoever can stump me gets a free beverage at the September meeting. So I will pause there and wait for questions. All right, and they all came in a bunch. So my co-PI on Epic says, you've covered a lot of material here. If we only have time to do one thing, what would you suggest we start with? I like this question, and I'm going to give the answer that nobody probably wants to hear. Talk to your scientists. It doesn't take long, and it's the thing that is going to give you the biggest amount of intelligence to go on. And I've always couched this in one of two ways. The first way that you can do it is you sponsor a pizza party or something where you have tell us about your science day, and you put it in one of your public facing facilities on campus, and you put up some poster boards and go and buy the local cheapest pizza you can get, throw some sodas in. If you're doing it at night, maybe throw in some alcoholic beverages, whatever you want to do, and have the people talk about their science. Have your IT staff go around, write stuff down, offer to come back to their facilities, offer to watch them. Whatever the case may be, you're going to learn more about what they're doing and how they interact with your technology than you ever will going to one of our community meetings and hearing somebody else talk about it. You know, I can't solve that problem for you. I can give you the tools to try to do it, and that's the tool that I would give to you, is to watch what they're doing, ask questions, figure out how you can fix the things that they claim are bothering them, vexing them, preventing them from being successful. The second question was from Jennifer at Kimber. How do you see this exhibition impacting and benefiting STARRP activities? Well, you may get the beer, Jennifer, because I don't know. I don't know a lot about the STARRP activities, and I think it's because these are not very well defined. A lot of the things that are being done in the STARRP space are a little bit of a mystery to me. I know that the efforts are meant to sort of improve outcomes, but how are we measuring them? How are we learning from the mistakes or the positive things that are being done? So I don't have a lot of visibility there. I think that really we don't need to be having a conversation about, oh, here's this new infrastructure that we need to build. We need to be having a conversation about, here's how we improve things for these groups of people, or here's how we create strategies so that we can learn what the requirements are and then go back and have the discussion about what the infrastructure needs to look like. And it's a chicken and egg thing. It's a cart before the horse thing. And you can solve the equation either way. You know, one of my roommates in college used to always irritate me because he would solve calculus problems backwards in my mind, but it made sense to him. So if you can get the right answer to this, that's fine. My solution is to start with the scientists, though, and not start with the technology. And hopefully a lot of people can see the benefits in trying to do it that way. From Kate, have you heard any science success stories in other venues? Kate, I'm going to ask you to clarify that a little bit more because I don't understand your question. Tim, how to do all this in a highly resource constrained people environment? I guess that's more of a statement than a question. If you're asking how can you do this in a highly resource constrained people environment, let's back up a little bit and talk about how you can get more resources. When I originally started with ESnet and some of my prior lives, science engagement was always done on found cycles. It was done the thing that you had after you had done with your regular work. So I would claim that that's a resource constrained environment. But it became a full-time job because we were able to point back to the success and happiness that we were able to give when using those found cycles. So for example, going and spending a day with a scientist, that's an investment of 1 FTE for 1 day. And I get it. That's something that it's hard to argue when you have to do security patches or you have to do printers or you have to do whatever your day job happens to be. But what's the cost benefit analysis? What do you get out of spending the day with that scientific group? Well, you learn a couple of things. You may learn that there's areas of friction that they're not reporting. You may learn that there are processes that they do that are just inefficient for the infrastructure that either exists today or could be put into the future. And you may also learn that, you know, they're just really starved for somebody to understand how to improve things for them, either because they can't do it on their own or because they're just unable to do it because they don't have resources either. All of these things need to be reported back to the people who hold the purses and the pocketbooks above us, right? Because what ends up happening is that if you can show some change for one scientist or one researcher in one department somewhere, they're going to go back and talk to their friends and say, hey, look, they convinced me to do it this way. Maybe I'll help you do it, or hey, maybe you should just go and talk to them. So you build your own list of people who need this help. And once there's a list of people that need the help that far exceed the resources, not even the original amount that are asking in the beginning, but far exceed it, it's easier to go back and say, hey, look, people are really itching for this. They really need this. We need more resources to be able to do this. Because once we can upgrade the infrastructure, once we can upgrade the abilities of things to help out these groups of people, we do better as a university or we do better as a facility. We can go after more funding resources, we raise our own visibility, we can attract more talent. So it is a self-fulfilling prophecy once you can get started with it, but you have to start the snowball somewhere. And it often means a little bit of short-term pain for long-term gain. So I hope that sort of addresses what you were after, Tim. And Kate has the clarification. What science has the CICI STARRP series of grants produced? I don't know the answer to that question, so I guess I will offer you a beverage of your choice as well, Kate, because I don't think we know that information. It's not something that I regularly hear when I talk to people who have these grants. They're not talking about, oh, the bat biologist is doing better now because of this, or oh, you know, the volcanic people are now able to go in and do this. This is a step that we often skip, and we can't. We need to go back and we need to address this. one would hope that infrastructure that we put in place is raising all boats. I honestly hope that it is. But I hear more examples of, well, we built this and we didn't see the usage. And then when we dig a little bit deeper into it, we find out that it was hard to use. You know, there was policy put in place or burdens that the groups of people that it was designed for felt that they didn't want to do. So then we have a situation that looks just like my campus map, where we have nice concrete walkways and bare patches of earth where people have walked because they're doing the thing that is easiest for them to do. And I don't want that to be the answer anymore. I don't want to hear about hard drives being shipped. I don't want to hear about frustration with IT. If we can build up the relationships, we hopefully will not have that happening as much. It's always going to happen, but hopefully it will not happen as much. All right, from Mr. Deaton, the act of putting in the hardware and creating the relationships across research, IT, and regional have had success in resolving data movement issues. Not necessarily the DTN, but the new frictionless interaction from the new relationships. Well, I hope so. I want to hear more of those stories. I want to hear about how a regional computational infrastructure coupled with a regional grant infrastructure, regional network infrastructure funded by these things has fixed these problems. But as long as I keep doing deep dives and as long as I am able to talk to individuals that have not realized this yet, I'm still not 100% convinced there. So one of us has to be the contrarian. So I'll still continue to play that role. I think I do good at it. I want this to be the case. Let's hopefully get some more examples of this out there so that we can all learn from the pluses and negatives that we've seen as we do it. So it sounds like I owe Jennifer Oxenford and Kate Adams beverages when we are in Minneapolis. I'll pause another minute here and see if anybody else has any last questions. From Hans, it would be good for these folks that have done this to participate in this exhibition challenge. Yep, absolutely. And this is why the exhibition challenge is open to everybody. And it should be done using production hardware, not just something that's built for the sake of winning a golden ticket. We want this to be what the scientist uses to do their stuff right now. All right, I'm gonna end it right there. Thanks to everybody for the questions, the conversation. This will be continued on the mailing list as well as when we are on site in Minneapolis. Hopefully everybody will want to participate in this event. The information will be coming out very shortly to show you how to do it. We do not have a talk next week, but we will have one the week after. And I believe it is William DeGard from Texas A&M, and he is going to be talking about Batfish. And I believe Batfish is some form of automation and testing framework, but I do not have that in the forefront of my mind. So otherwise, it may be a superhero. Who knows? Hope everybody has a good holiday weekend. We will talk to everybody soon. Thank you so much for attending today.